Hello everyone. Today we are going to discuss about software quality assurance. Myself, R. Punita Gauri, working as assistant professor in CSE department at Erode Singhodar Engineering College, Tudupadi. So what is software quality assurance is? It is simply a way to assure quality in the software. It is uh, it is having a set of activities which ensure processes, procedures as well as standards that are suitable for the project and implemented correctly. Simply says that SQA is a process which works parallel to development of software. It focuses on improving the process of development of software so that problems can be prevented before they become a major issue. SQA is a kind of umbrella activity that is applied throughout the software process. So from the beginning stage of the software product development and till the end of the software product development, the software quality assurance have to be ensured throughout the development process from the beginning to the end. So before getting into the details of SQA, we need to know what is software quality. So quality is a term which is different for various products. As here, our product is a software product. So how we are going to measure or assess the quality means we are having different definitions. A scientist's kitchen man refers to software quality as fitness for needs. Here we are going to develop a product only for the client needs. So at the end of the day, we have to fulfill all their needs and requirements given by the client. The developed product should fit the needs of the client. Uh, Typically, we can say that conformance to its specification, which means that all the specifications given by the client should be satisfied. At the end of the day, uh, all the specifications or requirements given by the client should be satisfied or completed. The next one, fitness for its intended purpose. So we have developed the software product for some kind of purpose which is given by the client. That purpose should be completed or satisfied at the end of the day. At the end of the day, a client should be happy with the product. So that is what software quality defines here. The Department of Defense (DoD) defines software quality as the degree to which the attributes of the software enable it to perform its intended end use. Again, for what purpose we have developed the software should be satisfied or completed. Then only the customer can be happy. So that defines the quality of the software. Here we are having different views of quality. We can view the software quality as a multidimensional construct, polyhedron metaphor. So consider a cube. So in each side of the cube we will be having different parameters. First one, timeliness. Within the given time period the software should have been developed completely. And the next one we are having cost. So what is the cost for the software product development from the phase 1 to the last phase? What is the cost required for the development of the product? The next one, functionality. Yes, functionality here means that the requirements given by the client that should be satisfied. And then correctness. So after giving so many corrections, the software should get adapted. Then reliability. And the end of the day, the software product should be reliable one. And maintainability. So we are going to maintain the software for few years. So how the changes will be adapted and how it can be maintained. So all these things are defines the quality of the software. So these are all the like a metrics or parameters which are used to define the quality of the software. Next, we are having different kinds of models for developing a software, for measuring the software quality. In order to compare the quality in different situations, both qualitatively and quantitatively, it is necessary to establish a model of quality. So here we are having different models. So all the models are in hierarchical view only, which means we will be having phase 1, phase 2, phase 3 like that. A hierarchical model of software quality is based upon a set of quality criterion, each of which has a set of measures or metrics associated with. This type of model is depicted in the picture. Here the quality factor. Here we are having quality factor. In order to measure the quality factor, we are having some kind of quality criterion. That criterion will be measured or assessed using some quality metrics. Usually this matrix will be having some formulas or some methods to measure the quality. So after this metrics have been measured, that is mapped to the criterion, and after all the criterions have been predicted, which is mapped to the quality factor. So this is like a hierarchical model of the software quality. So majorly we are having, for example, here reliability is one of the software quality metrics which is used to measure the quality. Here the reliability metrics will be having uh, some kind of metrics associated with it. For example, reliability can be measured by means of accuracy of the product, consistency of the product, and fault tolerance of the product, and simplicity of the product. Here, accuracy says that the product should be very accurate one and consistent one, and fault tolerance. Here, fault tolerance means that what are all the faults, different kind of faults received from the customer or programmer or developer, that should be adapted and rectified easily with the product by using the product. And simplicity. So these are all different kinds of parameters which is associated with the reliability metrics. So the reliability metric can be measured using these kind of parameters. So after measuring the reliability, the we can map it to the quality factor. So generally we will be having two different models for measuring the software quality. So one is the GE model, it is the abbreviation of General Electrics model, and the next one is the POEM model. So these two models rule the software quality area. So GE model is slightly different from the BOEM model. So BOEM model is developed by the scientist Boehm McCall. Okay. So first we will look into the GE model. So GE model is also called as a GE model can also be called as a McCall model. This model is first proposed by the McCall in 1977. It was later adapted and revised as the MQ model. So GE model is also called as a McCall model, or else sometimes it will be called as a MQ model. The model is aimed at system developers to be used during the development process. However, in an early attempt to bridge the gap between users and developers, the criteria were chosen in an attempt to reflect users' view as well as developers' priorities. So here we are having different two different persons. One is the user who is going to use the product, software product at the end of the day, and another one person is a developer who is going to develop the product for the client or the user. Okay, so here the terms client and the developer and the user are different. Client is the sense the owner of the product, right, uh, who is going to pay the money for the software product. And the users here means maybe some workers in the owner's company, which means that client is the product software product owner, and at the end of the day, after developing the particular software product, the client is not going to be used with the product. So the client having some of the workers who is going to use the software product. So the here we are having two major perspectives. One is users view and as well as developers priorities. So this model combines both the users view and also it will give priorities to the developers also. The model identifies three areas of the software work. First one is the product operation and product revision and product transition. Here, in diagrammatically, we can represent the uh, GE model based on this diagram. So first one is the product revision, product transition, and another one is the product operations. So product revision having some criteria like maintainability, flexibility, and testability. So this will have three different criteria: maintainability, flexibility, and testability. And another one is a product transition that consumes portability, reusability, and interoperability. And the last one is the product operations. So this will have correctness, reliability, usability, integrity, and efficiency. So we will look into the each and every time detailing in later. First one is what is product operations. So product operation requires that it can be learned easily, operated efficiently, and that the results are those required by the user. Okay, so it should produce the results which are needed for the end user. Okay, so the product operation is this will have some criteria like correctness, reliability, efficiency, integrity, usability. At the end of the day, the product should operate effectively and it should be easy for the users to handle the product. And the next one is the product revision. So here the product revision is concerned with error correction and adoption of the system, which means that we are going to develop some software model and it will be revised each and every time. The corrections will be given by the client. So each and every time the corrections will be given or some features may be added to the product. So some features may be needed by the client. So we have to modify the product. So we have to revise the model repeatedly. So that should be done easily with the product. So the developed product should adapt various revisions. This is what given by the product revision. This is important because it is generally considered to be the most costly part of the software development. So for example, if the client is giving one another feature after developing and deployment of the product, so we have to add the feature in our software product very easily. So we don't want to change all the software modules so that it can be adapted, not like that. So one more feature can be added very easily. So that would be the better quality one. The next one is the product transition. So product transition means it may not be so important in all applications. However, the move towards distributed processing and the rapid rate of change in hardware is likely to increase its importance. So product transition means after development of the product, the complete product should be installed in the client environment and it should adapt to all the hardware and software and opera platforms in the client environment. It should be easy for transition, okay, from the development environment to the user environment. So these are all the McCall's criteria of quality. So here the usability criteria defines ease of use of the software. So the software will be very easy to handle because the end user is not going is someone who is not aware of the software, who may not be not much aware of the usage of the software. So it will be easy for everyone to handle the software. And the next one is the integrity. So integrity means the protection of the program from unauthorized access. So it should give the security to the product. So no one can easily access the all the software modules. Okay. The next one is the efficiency. So here efficiency concerned with the use of resources. For example, processor time, storage. So the product should be very easy for everyone and it also consumes less type of resources. The next one, correctness. So correctness means extent to which a program fulfills its specifications. So after getting all the specifications, it should be easy to adapt. And the next one is the reliability. It means that the ability not to fail. So anyhow, the product should get all the specifications and it get all the requests and it should be reliable to everyone. So at any time it should not get failed. Maintainability means the effort required to locate and fix a fault in the program within its operating environment. So after the successful installation and deployment of the product, if it get any fault or bugs means that should be easily fixed and located. Okay, so flexibility means ease of making changes required by changes in the operating environment. So ease of making changes required by the client in the operating environment. So it should be flexible for everyone for adapting changes. The next one, testability. So testability is ease of testing the program to ensure that it is error free and meet its specifications. Portability means effort required to transfer a program from one environment to another environment, which means that from the developing environment to, for example, from the IT industry environment to the end user environment. The next one, reusability, ease of reusing software in different context. So at the end of the day, we are going to reuse the code and the modules. So that should be very easy with the product. Interoperability means the effort required to couple the system to another system. For example, if we have developed one software product and we are going to use with the another software product, but it should get easily coupled with the different products, different software modules. That means the interoperability. So these are all the various kind of metrics associated with the McCall model. And the next one is the Boehm model. So Boehm model was defined to provide a set of well-defined, well-differentiated characteristics of software quality. The model is hierarchical in nature, but the hierarchy is extended so that quality criteria are subdivided. The first division is made according to the uses of mode of the system. These are classed as general utility or as is utility, where the as is utilities are a subtype of a general utility. So we will be having general utility. So general utility will be subdivided as is utility and maintainability. General utility means roughly equating to the product operation criteria of the McCall model. So there are two levels of actual quality criteria. The intermediate level being further split into primitive characteristics which are amenable to measurement. The two models share a number of common characteristics arising from their hierarchical nature and also from their origins in computing culture of the 1970s. The quality criteria are supposedly based upon the user's view. In practice, they represent a designer subset. There are some curious different definitions provided for the criteria. The models focus on the part designers can more readily analyze. For example, the criteria included all are connected with the technical aspects of the software quality. So the same in Boehm model also we will be having the metrics which are device independence, completeness, accuracy, consistency, device efficiency, accessibility, communicativeness, structuredness, self-descriptiveness, consistency, legibility and augmentability. So each of these criteria with mapped with the some quality factors. For example, portable is a quality factor which is mapped to device independence and completeness. And another one quality factor is reliability. So here reliability is mapped with completeness, accuracy and consistency. And the next quality factor is efficiency. Efficiency is mapped with the device efficiency and also accessibility. And the next quality factor is human engineering. Human engineering is mapped with accessibility and communicativeness. And the next quality factor is testability. Testability is mapped with the accessibility, communicativeness, structuredness, and self-descriptiveness. And the next quality factor is understandability. It is mapped with consistency, structuredness, self-descriptiveness, conciseness, and legibility. And the last quality factor is modifiability. It is mapped with two quality metrics. First one is the structuredness and the next one is the augmentability. And the quality factors testability, understandability, modifiability is mapped with the maintainability product. And the reliability, efficiency, human engineering quality factors are mapped with as is utility. So this is like a hierarchical model. So Boehm model is also a hierarchical model. So both the McCall model or GE model and the Boehm model is ruling the software quality assurance area. So next we will move to the quality measurement. A software metric is a measurable property which is an indicator of one or more of the quality criteria that we are seeking to measure. Which means that as such, there are a number of conditions that a quality must meet. It must, it must be clearly linked to the quality criteria that it is seeks to measure, which means that we should map the quality criteria to the quality measurements. And it also sensitive to the different degrees of criterion. And it also should provide objective determination of the criterion that can be mapped onto a suitable scale. So these are all the different ways to measure the quality. Measurement techniques applied to the software are more akin to the social sciences where properties are similarly complex and ambiguous. A typical measurable property on which a metric may be based is structureless. The criteria of quality related to product revision, maintainability, adaptability, and reusability. So all are related to the structureness of the source code. So all the quality criteria, for example, product revision, product maintainability, adaptability, reusability, all these product criteria are related with the structureness of the code. So here we can calculate the structureness of the product using the formula given here. And here the soft structureness may be calculated in terms of the average length of the code, which means structureness is directly proportional to the modularity, and it is also directly proportional to lines of code divided by number of modules. So we are having uh, less number of modules and more lines of code means the structureness will be increased. So this should be a well-structured code is characterized by only one entry point to and one exit point from each model. So when we can say that the product is a very structured one means that should have only one entry point and only one exit point. The next one is the software metrics. So here metrics are classified into two types according to whether they are predictive or descriptive. So a predictive metric is used to make predictions about the software. So for example, in last slide we have discussed about structuredness. So structuredness is one of the predictive metric that is used to predict the maintainability of the software product which is going to be used in the client environment. And another one metric is type of metric is descriptive metric. Descriptive metrics describes the state of the software at the times of measurement. For example, in last slide we have discussed about the reliability metric. It might be based upon the a number of system crashes during a given period time. And we have discussed about two hierarchical models. First one is the Boyer model and also a Meckel model. So both these models have been adapted for different metrication methods. For example, a Boyer model adapts the checklist which are required for yes or no answers. So Boyer method will be having certain kind of questions that are only yes or no type of questions. If the product have answer for all these questions, then we can say that the product is a well structured one. Okay, so the first question have the rules for transfer of control between modules been followed? So we will be having certain conditions, certain rules for transfer of control between one model to another model, that all those rules should be followed in the developed product. So for this question we are going to say yes or no, right? And the next one is the models are limited in size, because the size of the model should be reduced, which means minimized one. So the large model will be having large number of bugs. It is not easy to adapt and it is not easy to remodify. So the module should be in limited size. So all the modules in the developed product should be limited in size. As usual, this question also will be having yes or no type of answer. And the next one is the do all the models having only one entry point? A well structured, we have already said that a well structured program, well structured model will be having only one entry point and only one exit point. So in each module, in every module, we have to follow that point, entry only one entry point and one exit point. So if we can say that a well structured program, if all the above questions will having the answer yes means we can say that the product is a well-structured program or well-structured product. Similarly, in McCall's approach, we are having some kind of methods which are more quantitative one. So in previous one, we will be having some predictive one, yes or no type of questions. Here, McCall model is more quantitative one, which will be like the numbers in integers. So the scores are derived from the following equation. So McCall's structureness matrix is calculated with the formula using N01 divided by N total. Here N01 means number of modules containing 1 or 0 exit points only. So at the each and every model should be having only one entry point and one exit point. So here 0 exit point means that the last module is not going to have any exit point. So the first module means there is no uh, we are having one entry point and one exit point, but in the last module we don't have any exit point which is not connected with any further module. So number of modules that are containing only one or zero exit point divided by total number of modules in the whole software product. So here the Becquerel structureness matrix will be in the range of 0 to 1, so that we can easily compare with the other modules. Okay, so this is how we are going to measure the software metric based on the predictive measure and also the descriptive measures. Okay, thank you.